let's do some more examples. So let's look at a different study. And in this study, we're going to, I'm actually going to erase it. We're going to look at drugs. Okay, so we're going to say that we're doing a study on a new drug that came out, and we want to see whether that drug is effective or not effective. Okay, so to do that, the first thing we have to do is we have to figure out what is the null hypothesis and what is the alternative hypothesis. So we want to do a study to see whether a drug is effective or not. And we could do that by giving half the group the drug and giving half the group a placebo drug, and then analyzing the results to see whether the drug is effective or not. Okay, so the first thing we got to do is we got to figure out what the null, let's look at the null hypothesis. So null is H naught. The null hypothesis is that, remember, a null has the word not in it, right? So I'm going to say that the null hypothesis is, oh my gosh, my writing is horrible today. It's just so hard to write on a computer screen. So the drug is not effective. Okay, and then the other hypothesis is known as the alternate hypothesis, also known as the research hypothesis or your actual hypothesis, is that we're going to conclude, or we're going to hope rather, that the drug is effective. Okay, so again, null hypothesis is where you have the word no in it, so not effective. Your actual or alternative or research hypothesis is that the drug is effective. So moving on from, or continuing on rather from last time we looked at some p-values and we decided whether to reject or accept the null hypothesis. So this is what we're going to do around the same thing right now. We're going to look at this example over here. So let's say the alpha level that the researcher chose is 0.05. Okay, so I'm going to use this example here because this is the most common one that researchers use. Okay, 0.05, and the p-value, so when I did this study and I computed all my results, I got let's just say 0.028. Okay, let's analyze this. Okay, so what I normally do is I take the p, and the p is 0.028. I'm just going to write that underneath so that we can see it. And I take the alpha number and I bring it down, so which was 0.05. Okay, now we got to figure out whether this number is higher or lower than the alpha level. And so think about that. Is this number higher or lower than this? So this number is lower, right? You're eating up the bigger number, it's lower. And when it's lower, we're happy, right? We're happy because what does this mean? This means that we can reject the null hypothesis. This means that we can say no to this and yes to this. And now we would conclude that the drug is effective. Let's look at a different example. So let's say I'm going to change the alpha level here. Let's say the alpha is 0.01. Okay, so 0.01, and my p-value is, let's make it kind of similar. So I'll just change it to 0.024, okay? So let's look at whether this is good or not. So what I do is I bring the p down, okay, and p is 0.024, 0.024, and I bring the alpha level down, which is 0.01. I don't know why the computer keeps making that line. Okay, anyways, there's a point here. Okay, so now what I want to do is I want to figure out whether this number is higher or lower than this number over here. And if you look at 0.02 and or 0.024 and you compare it to 0.01, 1 is smaller than 2, right? So unfortunately for us, in this case, p-value is bigger. So we're eating the bigger number. It's bigger than the alpha level. And when it's bigger, remember, we don't like it when the p-value is bigger. When it's bigger, we are sad. So the researcher is sad because now what the researcher has to do is, I'm just going to erase this. Oops. Okay, so I'm going to erase this over here because that was the old one. So now when the researcher is sad, what that means is that they have to reject the null hypothesis. That means that they put an X here and they put a check mark. Oh, I'm sorry, my bad. What that means is, let's erase that again. Not letting me erase it today. Okay, I'm sorry. So when it's sad, what it means is fails to reject the null hypothesis. That means that they have to accept this. Okay, they have to keep the null hypothesis, right? You're going to keep the null hypothesis when you're sad, and you are going to reject the alternative hypothesis, okay? What we usually talk about is null hypothesis. So you'll see here, when we refer to hypothesis in stats, we always refer to the null hypothesis. So here we are rejecting the null hypothesis. Sorry, failing to reject the null hypothesis, which means that we are keeping the null hypothesis, okay? So that's why there's a check mark here, and we have to, if there's a check mark here, we have to say X here. And so what this means is that we're going to have to conclude that the drug is not effective. Forgive my messy writing. Okay, let's conclude. Oh my gosh. Okay, I'm sorry. My writing is horrible and my computer is acting weird right now. But let's just summarize everything one more time. So, null hypothesis has the word no or not in it. Alternative hypothesis is your actual hypothesis where you think your study will work, where you think the drug is going to be effective. This is the rule that we always have to go by. When you look at the p-value number you're given, if it's higher than the significance level or the alpha level, then that's bad. It's bad because we have to say yes to this. If your p-value is lower than your alpha level or significance level, like in this case here, we're happy. Because when we're happy, we reject the null hypothesis. We say X to this, and we say yay to this, that the drug is effective. So this is important. Remember this for your test, because I will be giving you examples such as this, where you will have to identify whether the drug is effective or not effective. You will have to identify whether to fail to reject the null hypothesis or to reject the null hypothesis. Okay? Good luck with this.